So what is an addition polymer? Well, an addition polymer is formed when you take a monomer, which in the case of specifically addition polymerization is going to be an alkene, so it has a CC double bond, and is turned into a long chain polymer where the double bond breaks and becomes a single bond saturated, and then produce this idea of a repeating unit. So the way that I like to think of a repeating unit is, to use like computer terminology, it's like the simplest unit you can copy and paste to make the long chain polymer. So a polymer is going to be really, really long like this and so on. And then the repeat unit is just the simplest building block. If I just zoom in and say, just take a small part there. So that is basically what I've just drawn there. So it's the simplest building block used to create the long chain polymer. Now what we're going to start with is the classic one, the easiest one, which is ethene, which produces polyethylene, one of the the first plastics made. And it's a really simple equation. You can see all you have to do is just break the double bond, redraw it with a single bond, and then you have the two lines coming out either side. So our finished answer is quite simply that, with the lines there. And in a polymer, so for example, a typical polymer could contain upwards of 2,000 monomers, and even more. If you don't know the definitive number of monomers, then just like in maths, you just put X, or in the case of chemistry, N. So you have N number of them would produce a polymer with N number of repeat units. So that's if you've seen that N notation before and you've confused, it just means a large number of these monomers to make the polymer. And then finally, just a quick run through of how to name them. So it's really, really simple. So if you know the name of the monomer, which is in this case ethene, to work out the name of the polymer, it's just the name of the monomer again, and all you do is you just put the word poly before it. So the name of this monomer is polyethylene. It's as simple as that. Now this one, the next one, which is propene, this one catches students out because it doesn't look like ethene. So what you have to do is, when you get something that isn't going to be ethene, which is going to be a lot of the time because it's the easiest example, you have to make it look like that first. And the method to do this is very simple. You take the double bond and you do 4 lines coming off of it. And then if I start with this carbon, I put a blue dot next to, that carbon is that one. I go around clockwise and see what is attached. So I can see that starting here, which is this line, there's a hydrogen there. Then if we go the next one along, that other carbon is a hydrogen at the top as well. Then the other bond coming off the carbon on the right is also a hydrogen. And then when I get back around to this carbon, I can see that there's a bond coming out here, and that's attached to a carbon with 3 hydrogens. Or if I just put like a little bubble around it, you treat that as one whole thing. So it's attached to a CH3. You're aiming for a double bond with 4 different things coming off of it. If it's a complicated one, so something there, A, B, C, D. And then once you're in that position, then you could go ahead and write the repeat unit. Because all you have to do then is break the double bond, make it a single bond, and literally draw the same thing again without changing anything, and then put the lines coming out to either side. So that's the easy bit. The hard bit is changing it from this into this. But providing you follow the method I've just shown, which is to draw a double bond, do 4 sticks, 4 lines coming out either side, and then go around slowly to determine what is bonded to each carbon. Then you can set yourself up so that it looks like this to make the repeat unit, which is that. This one here, which is butene, or but-1ene, because the double bond is on the first carbon, is probably the hardest example you would see at GCSE Chemistry, grade 10 chemistry. So again, I don't like the way that looks. I need to make it look like ethene before I can do my polymerization equation. Okay, so don't worry about doing this working on the exam paper. If it takes you 10 seconds longer, then so be it. The main thing is you get the correct answer, and then you can put it in an equation form. Same thing again. Let's just do the work in here. So double bond, 4 lines coming off of it. That carbon there is that one there. And I can see immediately on the dotted carbon, what have I got? There's just 2 hydrogens. So there's hydrogen, hydrogen. Then on the next carbon, what have I got there? I can see there's 1 hydrogen, and then the other thing is CH2, CH3. And now suddenly, just remove my little symbols, I'm in a position to go ahead and write the repeat unit. So that is going to be, let's give a name to this one. This is but1ene. So this would be polybut1ene. The next one is a horrible one. It really catches students out because of this ring structure. So, by the way, these ones you're only going to see in advanced placement A-level chemistry. So GCSE students, you will not get anything as hard as this. But the method is the same. At the moment, it's drawn in skeletal form, and that might be hard to visualize the repeat unit for. So again, what am I going to do? I'm going to draw it out in a displayed form. So by the way, these have been displayed forms, so I can see what's going on, and then I can go back to turning it into a skeletal form for the final answer. Again, don't worry about doing this work and just get the correct answer. So CC double bond, and I can see that carbon there with a dot is that one there. Now with skeletal formula, think about it. What is always left out? It's the hydrogens, isn't it? Coming off of that edge there, there's actually a hydrogen there, and there's a hydrogen there. And on these corners there, there's a CH2 there and a CH2 there. And so now that gives me a bit more clarity. So what I've got is, that's a CH2, there's another CH2, there's another CH2, and there's another CH2 there. So what I've got, if I draw this displayed, is something that looks like this. Now I can see that. Well, I can do my repeat unit for it. Again, I'm going to keep it in displayed form for the moment, even though the question is not requiring that, because it's got to be in skeletal, and I'll show you how to change it back at the end. So again, double bond becomes a single bond, hydrogen there, and then we get line out there, and then the bracket there, and the bracket there. To turn that into skeletal form, so you've got something that looks like that, which looks kind of weird, doesn't it? It looks wrong, but that's what it is, okay? So the hydrogens, if I were to put them in, so that one there would be this one there. That's what they would look like, but we don't because it is a skeletal form. And then if you asked to join 2 of them, then you just have the same thing again. You'd have your square bracket there going into the next one, and then straight through, and so on. Finally, with this one, we are given the repeating unit, and we have to work out what monomer has been used to make that repeat unit. So, same method again. Start with a double bond, put the 4 lines coming out, and then look for a repeating pattern. Remember, the double bond is the only part that polymerizes. That's what breaks to form the single bond. So you're only looking for 2 carbons. Now, hopefully you can see there are 3 repeat units joined together here, because we have a CC double bond there, another one there, and another one there. So there's actually 3. So if I just focus on one of them, this is the way to do it. That one, it will get us to our answer. So we can see this carbon here with the dot is this one there. So what have we got? On the top, we have a CH3. On the bottom, we have another CH3. Then the next carbon along, this one is this one. We have a hydrogen, and then another hydrogen. So my final answer, get rid of my workings, is that molecule there. That's the monomer.